Ladies and gentlemen, please welcome to the stage, Cristobal, José Colón.
Thank you for the opportunity to be here to present in this amazing roundtable. I would like to start with a few words about the context. I think we live in an era of time acceleration and space extension where technology is the key element that enable this transformation. In this context, I think that 3D printing or additive manufacturing will bring a new revolution in terms of manufacturing flexibility, lead time, cost, go-to-market, and new materials to be used. Additive manufacturing was essentially used in rapid prototyping and tooling application. However, the EM industry has been evolving at an unprecedented pace recently. Three catalysts have driven its swift evolution: sustainable cross-sectorial demand, increasing maturity of technologies, and the consolidation of a competitive ecosystem. As IM matures, it will not only offer new and more performant products, but also superior agility, new means of diversification, and potentially lower overall costs than the conventional processes. Time for questions. The first one, as we see, EM is essentially used in rapid prototyping and tooling application, but the key question here is when EM is going to be a mass-scale technology in the automotive industry. And I would like to start with you, Christoph.
Well, I think it's a question of choosing the right product. And also it's a question of what do you really see for mass production. As I've shown in my presentation, I have the feeling we are already in a mass production. But in terms of automotive, for Volvo, for example, this is not really mass production. I think it's all a question of the few and what you expect. But for sure, there is a lot of room to improve and a long way to go.
David?
I think, as we have seen by your example and other examples, there are already business cases. There are good examples that we've seen afterwards as well. But as costs go down, the applications will go up. Right now we see not too many applications. It's not a complete car, it's not a complete truck. So when costs go down, we can see this go up. So to me, it depends a lot on when costs go down.
Yeah, absolutely. Yes, I agree with Christoph and David as well. It's not 3D printing is not for every industry. It's not for every application. It's not. It's this utopian dream of 3D printing anything and everything that you want, but it makes no business case. If you take in our case, we specifically work for low volume, high value companies, and it makes sense for them to adopt 3D printing. If you take a lot of automotive OEMs, they're going away from being automobile manufacturers to brand management companies, in a sense that they want to manage fleet of skateboards or fleet of cars. In that case, if you want to have everything in-house, 3D printing makes sense. To go from design to iteration much more quicker, and to have the parts quicker when you have level 3 autonomy as well. Right now, not so much. When you have 72 million cars were produced in 2018, the speed and the cost per part is just too high to get into mass production at this point in time.
So from my point of view, at the end is, as David said, the first thing is to identify applications, to get more and more to be analyzed for additive manufacturing. So far, there are not that many, but we know that there is a need in the market, so the people are doing this effort to identify these kind of parts. And there is a second one that is also the economics. We have always to talk about the break-even point. What is the point below that the additive manufacturing is more, let's say, economic compared to traditional manufacturing. Usually the injection molding, and also Adrián probably will agree with me that the design capabilities will also enable part of these issues. Not only the searching, the research on materials and application, but also the design will be also an accelerator on this.
Yeah, I totally agree with my colleagues. It's about cost, but also it's about changing the mindset of the engineers. I'm a mechanical engineer. I work together with people that they have been working for the automotive sector for 40 years, and they don't think about this technology for a final solution. They are changing right now their mind. So I think this is a really important driver. No? All the colleagues, we have to start thinking in this technology as a real solution for production.
Thank you. And talking about the changing the mindset, so how far 3D printing is going to boost or is boosting the innovation in automotive or in other parts? So it's a key question also, because you have no limits like before.
I think the technologies enables a lot. As you've seen, for example, with the example of the chassis inserts, it opens up several ways. And but there is a need of change also in education, because the engineers coming from the universities, of course, they've seen some additive manufactured parts, but the way of developing a part, of designing a part, has to change drastically. As with the topology optimization, you've shown quite nicely. The way how you approach or tackle an issue is completely different, and this has to be changed already in the education of the engineers.
Yeah, I think 3D printing for mass production, it's really a good time for it to start working now, because we are also seeing large changes in the automotive industry. We see self-driving vehicles, connected vehicles, electrification, and that will definitely change the design of the vehicles. It will change how we use the vehicles. And then we have this new way of producing parts. So if we think about the mindset, as mentioned before, when we are now reinventing vehicles again, then we can really embrace this. So I think we will see more and more applications and more areas where we didn't think about it before. It would just happen now.
And I'm going to go back to Christoph's statement before. I think it's the education and awareness that the term 3D printing itself is quite wrong, because it's additive manufacturing. Again, you might ask it's the same thing, but it should instill a confidence in a lot of people. Because if you take my cousin, who's just 8 years old, when I tell him it's 3D printing, he goes back to your plastic toys. They don't really go back to your advanced metal 3D printing. So the education and awareness has to come down, has to go up. And second of all, it's the design for additive manufacturing that needs to be the focus, and not the 3D printing as a hardware solution that needs to be the focus on. And as David mentioned as well, at this point in time when electric cars are being reinvented, because we have this predefined notion of what a car really looks like, and with design for additive manufacturing, we can make cars much more compact as well. So these are sort of the end-use application that's not really out in the market. A lot of people focus 3D printing on cool stuff, you know. It's not really good in a sense that the current market focus is just on PR producing opportunities and not on end-use applications.
Mm-hmm. Well, I think that 3D printing, additive manufacturing, digital manufacturing are similar, let's say, concepts. But when we are talking about specifically of 3D printing, there are more focused into prototyping, jigs, tooling, and so on. That is something that is already applied for 30 years or 25 years in the automotive industry. And I think in this kind of companies, they have already the mindset how to apply the 3D printing for these things I already said, the tooling, the jigs, and the prototyping. Now, what we are seeing, at least from HP side, is that many OEMs, for not say most of them, are applying this kind of technology, the ones that are more reliable, to really think and find applications to produce a real mass production. When we are talking about real mass production, coming back to the previous questions and answer, is related to the break-even point at the end. So we cannot say hundreds of thousands of parts to be produced with 3D printing or additive manufacturing, but probably now we have the opportunity, because electrical vehicles, because of bus and trucks, that is Volvo also saw before. For this kind of applications or products, the break-even point probably is more in the side of 3D printing, and as I say, this kind of technology that are producing real reliable parts, let's say.
In my opinion, 3D printing is for sure one of the main drivers for promoting innovation. I mean, you are breaking a little bit the rules. It's not all possible, but you can think outside the box and even be inspired about your your environment in order to find the best solution to the technical challenge. As, for example, Revannth said before, this caliper that seems like a heart is something that you cannot do it with traditional manufacturing, no? But with the 3D printing, it's able to do it. That's a really nice point of this technology.
So, but in this context, as you say, you can print or manufacture this kind of parts everywhere. You can manufacture when you want. And what will be the role of the providers for the automotive? Because if an OEM can produce this kind of parts for itself without any tooling or any kind of additional machine, what will be the role of the providers? And what will be the relation between the OEM and the other suppliers?
I think this will or can change a lot of things. So first of all, you do not really have to produce in your facility, so you can really produce directly on site at your customer or at the manufacturer. This can change also the complete way of delivering parts. So the lead times will become much shorter. But we all have to cope with this. This means a complete different way of logistics. And I think you have to consider this even more than me, but I think it will change dramatically your life.
Yes, it will change, but I think at the stage we are now, we are more focused on the repeatability of producing a part, getting the same quality every time. Next step will be then decentralized, and then maybe we can do it in-house, but our expertise is building and selling trucks. It will never be that specific as HP or others that are really good in these things. So, yeah, and in the end, why doesn't the customer print themselves? Maybe we will just sell them CAD files so they can print everything themselves. So it doesn't stop with us as OEMs. It can go even further to customers.
Yeah, I completely agree with Christoph and David in a sense that when you talk about OEM and their relationship with service providers as well, and you talk about decentralization, that of course is quite in the future. As David mentioned, you just can't expect an OEM to sell you a CAD file or an STL file and ask you to print a car for yourself. That's of course a utopian dream that's not going to happen anytime soon. I guess where decentralization adds much more value, of course, is reducing the cost, time, and carbon dioxide emissions associated with, logistics, warehousing, and et cetera, et cetera. So you don't need to put hundreds of thousands of cars on a ship and trains and trucks. You could rather send a digital file across to Germany or South Korea and have it locally 3D printed. But of course, as David mentioned as well, that's going to be quite in the future. You need a lot of things about regulations and IP management, et cetera, et cetera. This is an area where blockchain could actually play an important role. And I mentioned in my slide as well, I don't really have a time. It's still in the infant stages, but you could use blockchain to trace the way back to the supply chain and also store STL files on the blockchain as well. So it's not non-infringible, if you will.
So when you think about this, the supply chains or the connection between the OEMs, tier 1s, tier 2, and something like this, and all the rest of the partners that we can imagine, the relationship will change, and in fact they're changing. But if we look behind, or if we look forward in the future, probably we will start having all these kind of companies that are, let's say, distributed by the world. Because at the end, the tier 1s and the tier 2 are the specialists to producing parts, and they won't lose the capacity to produce parts for their OEMs. And probably they will move and they will distribute their production. From the SP side, because we are working on this hard, not only for the automotive, but also for other industries, like the heavy industry, packaging, and medical devices, and so on. What we are trying is to help this kind of OEMs and tier 1s getting to know and certifying companies that are having our technology around the world to have the opportunity, if I want to produce something in China, somewhere in China, somewhere in India, somewhere in Turkey or somewhere, whatever, we think. So we can provide to them the name and content of a company that have been certified. And this, I think, we are helping to these companies. They are looking, wow, what is happening with the supply chains? Where I can produce these parts? So we are helping them to have this list already done proactively from our side.
Yes, I think that, as I said before, this is breaking the rules, and for sure all the stakeholders of the value chain will adapt their business models and their proposals to this technology. As a tier one of automotive from IDNEO, I think we should be focused on continually bringing value on the design, on the development, where this technology is one of the main drivers to bring a really good solution, and also maybe to adapt our manufacturing facilities in order to bring value also with this technology.
Thank you. Well, one last question, but it's very similar to the questions talked about before. What about decentralized versus centralized strategies for manufacturers? And I mean with this, where do you see the risk of a decentralized strategy that maybe any workshop in the world can print his own pieces and then put it on the cars without any certification program and with any control? What will happen that if there is an accident or what happens, anything?
Well, you know, in terms of race cars, it's quite easy, so,
Yeah,
so it shouldn't be a big problem. But again, for you, this could be something critical.
I mean, we are thinking a lot about this. You mentioned it, the piracy of parts being a big risk for us. How can we make sure that the parts are the same quality? You can take and make a scan of the part and then you can print it yourself, but you will not get the same structure, maybe not the same material, these things. So of course it's a risk, but it's a risk for society more than I believe it's a risk for us as a company. It's a societal risk when we put dangerous parts on trucks in general.
Yeah.
That's mine. Yep.
Yeah, I mean, decentralization is all nice and good, but then again, if you think about 3D printing, what really needs to happen is standardization of 3D printing, you know, because as David mentioned as well, getting every single part that comes out of the printer having the same functional properties and mechanical thermal properties, it's really, really difficult. And of course, liabilities of 3D printing as well. Who exactly is going to take care? Is it the OEMs or is it the customer? Is it the 3D printing supplier? That's a lot of questions that needs to be really, really answered. So it's going to be really, really far ahead in the future, I reckon.
As David has said, there is a huge risk having, let's say, end users printing parts that are not certified and installing them into vehicles. But the thing that we have to do is to help at the end the end users, maybe you, the Volvo, to find, let's say, companies that are certified, or helping you to certify companies that are everywhere. And anytime that you have end users that want to produce a part and they have to follow all the process and the standards that are required for the business, go for these kind of companies that they can produce parts with the quality, expected quality, to avoid this kind of risk. At the end, I think it's what it should be in the future.
It's a really good question. Honestly talking, I don't really know how to solve this challenge for this technology. As IDNEO, what we do sometimes is maybe when a customer comes with a part traditionally injected with the traditional solutions. Of course, we are experts on the automotive sector, and we know all about the testings on the DVP and the PVT phases of certification and validation of a product. And yet, when we print a new solution, then we test it with the same test as the ones that were made in the traditional manufacturing, in order to ensure that it will also accomplish with all the requirements. When this solution is distributed, I don't really know how to solve it.
To handle, yeah.
Okay, thank you to everyone. I think I have 1 minute for I don't know if in the public there is any question for the speakers. We have 1 minute more. Okay.
Hello, everyone. I've joined the presentation many times, so maybe I don't know if you have already mentioned this topic before, but I'll just put the question aloud. Do you really think that the sweet spot in 3D printing? I'm sorry. Thank you. Do you really think that the sweet spot in 3D printing is the final component or the process improvement? Because, for example, in automotive, I would say, from my company, for example, in Voestalpine Additive Manufacturing, what we do is focusing not on the final design from the product, but on the injection molding inserts that we need to do in order to shorten the cycle time, which is one of the main headaches that the auxiliary companies are having. Usually, depending on the final customer, I would say it makes sense to do a final redesign for a tailor-made solution, but where do you see yourself, for example, getting inside these inserts to be 3D printable?
So maybe. So I guess the question is related if we have to focus something to the process of producing the parts.
Yeah, sure.
Okay.
Especially for the learning curve, because in automotive usually it's injection molding, high pressure die casting, hot forming, and cold forming.
Okay.
So based on those.
Yeah. So this is something that I'm facing every day with customers because I'm helping them how to select parts, components, how to adapt designs for additive manufacturing. So at the end, what we are trying to explain to customers today is you can go for the traditional way of producing or designing parts. This is something that is feasible. You can design your part for injection molding and then you can 3D print, but probably you are losing all the advantages that the additive manufacturing can bring there. So you can start with prototyping and learning all you can from the 3D printing that you are using, the technology that you are using to apply these learnings. Or you can go start today to talk with people that are really good today and to provide trainings and let's say trainings or hints how to produce or how to redesign the parts. So
I think that will work with the end consumer, the tool user, which could be Volkswagen, Volvo, or any other. But if you are working with, I don't know, a hot stamping for high pressure die casting or any other component that belongs to the tier 2, which at the end are manufacturing the car, the OEM is assembling and putting the label on it.
Yeah,
you know?
but
So the ones that are having the headache are the ones that are working for Volvo, for example, not directly Volvo. Volvo is innovating, as well as BMW, Volkswagen, and any other. But where do you see yourself helping the tier 2 and 3?
So then you will see in the future two things. One is that we are helping, at least as a OEM of 3D printers, HP. So we are helping to the end users, probably will be the tier 2 and tier 1 companies, to learn, because we have training sessions for everyone to learn how to use or take the biggest profit from the technology itself. And also we know, because we have most of the OEMs having the technology, that these OEMs will request from the top to bottom to all these companies to start getting parts that are 3D printed in the line. So you have to adapt today. So we know that this is something that is happening because we are helping these tier 1, tier 2. This is, for example, the case of IDNEO, that they are only proficient in design. So we didn't have to design nothing or teach them anything. But at the same time, you will see that you will have Ferrari, you will have McLaren, you will have SEAT in the future, you will have also JLR, many companies that they will start requesting parts that are 3D printed for the products at the end. Yeah. So
Thank you.
Another question? No more? Okay. Well, thank you very much for your time and for being here. It's been very interesting. Happy to see you again.
Thank you very much.
Thank you.
Thank you.